Okay, let's move into one-sided limits. Okay, so this is actually a piecewise function, which we talked about in our review. But we're going to move from the left side, which is going to be the left side of 2, so 2.1, 2.01. Keep adding those zeros in there. And that was going to be x plus 1. And then on this side, since we're going from the, I'm sorry, I did that wrong. That's supposed to be over here. My bad. Here we go. 2.1. There we go. That makes more sense. And from the left side, it should be 1.9. There we go. That makes more sense. So we're getting really close to 2 without ever touching 2. Okay, and on this side, from the left of it, we have the other piece of our piecewise function, the quadratic piece. Okay, so let's plug in what happens when, because we don't really need to use a calculator since we're just adding 1 on that left side. So this is going to be 2.9, 2.99. So you can actually see this is approaching 3, right? So that's approaching 3. And then from the right side, right, we're plugging into, I'll use decimals on this one. We're plugging into x squared minus 4. So I have 2.1 squared minus 4. 2.1 squared minus 4, which is 0.41. There we go. And then let's do 2.01. So 0.0401. Let's keep going. Add another 0 in there. I think you probably can see where we're going. 0.00401. I think it should keep adding a 0. Yep, 3 zeros, and then 4 zeros. Okay, so it just keeps adding zeros. All right, so this is approaching 0. So in terms of one-sided limits, as going from the left to right of piecewise functions, you can see that we're approaching different y values. So this one would be 3, and this one would be 0. Now, what you're going to essentially take away from doing one-sided limits is that if they don't approach the same value, right? In this case, from the left of 2, from the right of 2, they don't approach the same y value. One is 3 and one is 0. Then the limit as x approaches 2 of this function would not exist. Okay, so let me show you graphically. We did this before last week. But if we have a piecewise function, you need to start with that brace. If x is less than 2, is x plus 1. And then x is greater than or equal to 2, which is x squared minus 4. And close the brace. All right, so that essentially, if I look at it, is going to be, as I move to the left, or from the left, approaching 2, you'll notice, we'll get to my numbers here. There they are. We're approaching 3. And then from the right side, we're approaching 0. Okay, so that just confirmed the table that we did. Okay, now let's recognize an infinite limit. So we're going to be looking at this parent rational function 1 over x. And we're going to be looking at going from the left and to the right of 0. Okay, so we have x and 1 over x. And to the left of 0, negative 0.1, negative 0.01. Stuff we've done this many times now. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, and then from the right side, too many zeros. 1, 2, 1, 2, 3, 2, 3, 4, and 1, 2, 3, 4, 5. Okay, so let's plug in and see what happens as we're plugging in 1 over negative 0.1. Okay, so delete this. 1 over negative 0.1. So that's negative 10. You're going to see what happens as I keep doing this. Negative 100, negative 1,000, negative 10,000. See where we're going. Let's take 100,000 all the way to negative 1 million. All right, so we're starting with negative 10. You're just going to keep adding zeros. 100, negative 1,000, negative 10,000, negative 100,000, and finally negative 1 million. All right, same thing on the right side. Positive 10, positive 100, 1,000, 10,000, 100,000, all the way to 1 million. So we are approaching negative infinity from the left of it and positive infinity from the right of it. All right, so this is the interesting part. So we do have, from the left here, we have an answer for that limit. We're approaching negative infinity. We also have an answer as we're moving to the right of 0, all right, or to 0 from the right, that approaches positive infinity. But because I said earlier, if your two sides, right, from the left and from the right, they don't match, in this case, negative infinity and infinity do not match, then this limit, as you approach 0, does not exist. So let me graphically show you why that's true as well. Okay, so we have 1 over x. Right, so if I kind of center it here, right, as you're moving towards 0 from the left, see how the y values are getting smaller. I know it's weird to say, but smaller, negative, towards negative infinity. This one towards positive infinity, so they're not matching up. So that's why the limit does not exist. Okay? Okay, now all this leads to is kind of a way that you can look at infinite limits based on the exponent, right, that letter n, and if it is a positive odd number or a positive even number. So the one we just did was x to the first power. That's a positive odd number, so you can see it looks like this one here, right? It looks like this one graphed here. If it were a positive even number, then it would be where you have both of them are approaching infinity. And so that would mean that your limit as x approaches a actually does exist. It's infinity. Okay, so that's the difference. And it's kind of summarized in this table here. Okay. Now, the whole point of doing this is to show you that mathematically we can use limits to define where we have vertical asymptotes. All right, so if you have a limit as x approaches any number a from the left or from the right, and you get your values equal to infinity or negative infinity, or your limit as x approaches a of the function is infinity or negative infinity, then we have a vertical asymptote at x equals a. So let me show you here. Okay, so if I were to plug in 1 over x plus 3 to the 4th power, all right, so 1 over x plus 3 to the 4th power, you should see that as we approach negative 3, right, as we approach negative 3 from the left, we're going up towards infinity. As we approach negative 3 from the right, we're going up to infinity. So because they match, the limit as x approaches negative 3, right, because these both match and are the same, they're both infinity, the limit is infinity. Okay? And so we actually have a vertical asymptote at x equals negative 3. Okay? Now, you already probably knew the vertical asymptote part because you learned before this class that if you have any value that makes your denominator 0, that is a vertical asymptote. Okay, this last one. The last slide here is to essentially kind of put everything we've been doing together, trying to find functions from the left, from the right, and then just showing you what the actual value of the function at that x value is. So you can see the difference between sometimes the limit exists and it's that, sometimes the limit exists and the function is undefined there, and vice versa. So let's start with the first one. As you approach negative 4 from the left and from the right, you'll notice that we're approaching 0. All right, so this one is 0, this one is 0, and if they match, then your limit as x approaches negative 4 of the function is also 0. Now, if you just take a look at negative 4, when you plug in negative 4 of the function, your y value is 0. Now, those all happen to be the same. That won't always be the case. Let's look at negative 2. Negative 2 from the left, negative 2 from the right, both approach 3. So this one's 3, and this one's 3. Because those match, the limit as x approaches negative 2 of the function is 3. But if you were to plug in negative 2 to the function, it's not actually going to be 3. You'll notice it's an open circle when x is negative 2. So this is undefined. Let me do it a little bit thinner so you can see. So that's one of those where I always found it interesting in high school because you're saying the limit exists even though the function is undefined at that x value. Okay, let's try 1. So as we move from the left, we approach 6. So we move from the right, we approach 3. So we approach 6. Sorry, as we move from the left, we get to 6. As we move to 1 from the right, we get 3. Those don't match. So the limit as x approaches 1 of our function does not exist, DNE. But if you were to plug in 1 to the function, your filled in circle is at 6. So make sure you know how we found that. All right, the very last one. As you approach 3 from the left, we're approaching negative infinity. As you approach 3 from the right, we're approaching negative infinity. Those match. So the limit as x approaches 3 is negative infinity, but you'll notice that we don't have a value when we plug in 3 for x, so that's also undefined. And because those were negative infinities here, we know there is a vertical asymptote at x equals 3. Don't need to put that, but I'm just showing you, circling back to what we just did. So hopefully, this gives you a good introduction to limits. I know this is very brief. I know it feels like a long video, but it's very brief. So make sure you're reading the section from the textbook, reading those pages from Calculus for Dummies. It's going to help you understand this idea of limits.